can shoot me an email or a text, and I'll be glad to answer your question on the spot. So, as I mentioned, today we are going over lesson 6, 7, and possibly 8. Now, lesson 6 deals with linear equations in two variables. And what I have pictured up here is what's called the Cartesian plane. And the Cartesian plane is used to not only graph lines, but also plot order pairs and even graph linear inequalities later. Now, each quadrant tells you exactly how to plot a point, and if your x-coordinate, an order pair, let me backtrack a minute. An order pair is a pair of numbers that contain an x and a y value. For example, in the order pair 2, 3, the 2 x-coordinate and 3 is the y-coordinate. And as I mentioned, we use order pairs mainly in graphing lines and later on other type of equations. The x and y coordinates tell you how to move on the Cartesian plane. So if you look at this table right here, and y'all at any point, if you need to take a picture of any of the notes, feel welcome to pull out your phone and take a picture if need be. Now, if your x-coordinate is positive, then you move that many spaces to the right. And if your x-coordinate is negative, then that means you move that many spaces to the left. Excuse me. I think of the y-coordinate as an elevator. If your y-coordinate is positive, then that means you go up that certain number of spaces. And if your y-coordinate is negative, then that means you move down that number of spaces. So, wanted to tell you what the x and the y coordinates mean here on the Cartesian plane. Good morning. Now, one thing that we can do with the Cartesian plane and also the x and y coordinates is that we can complete a table for an equation. Now, I want to go over the different types of equations. We'll talk about the second type of equation in just a little while. But anytime you got x and y on the same side and they're equal to some constant c, then that's an equation that's in standard form. Now, one thing you can do is if you're given an equation and you want to complete a table of values for that equation, as is the case here with number 5, you got a partially filled table and we got to find the missing values. So all you simply do is in the first line, we'll replace x with 0. Two times 0, that essentially disappears. So you're left with negative 3y equal to 12. And when you solve this equation, we divide both sides by negative 3. So when x is equal to 0, y is equal to -4. So that's one ordered pair completed. The second line, we let y equal 0 now and find x. So we have 2x minus 3 times 0 equal to 12. Well, the 3 times 0 part disappears. That's actually 0. So we're left with 2x equal to positive 12. And the last step to solve this equation is divide both sides by 2. Therefore, when y is equal to 0, x is equal to positive 6. The last line, we're letting x equal to 3 now. Now we need to find the corresponding y value. So here's our equation. And wherever we see an x, replace it with 3 now. Multiply 2 times 3, that will give us a positive 6. Minus 3y equal to 12. And you have a standard equation that you have to solve for or get y by itself. The next step to solving for y is subtract 6 from both sides.
Where did you get the number 3 from?
Oh, it was given.
So why you want to use like the 6 or something? Because it was up there.
No, we put the 6
Look,
in.
6 in, okay.
Yeah, they're different order pairs. Yeah, this is a separate order pair, and this is a totally separate order pair. So we'll subtract 6 from both sides. And we're left with negative 3y equal to 6. And the last step, divide both sides by negative 3. So when x is equal to 3, our third order pair, we have y equal to negative 2. In my math lab, when you have to graph a line, all you need are 2 ordered pairs. But if you're doing this by hand, usually 3 is a good number. Now, it does not say in the directions to graph, but let's go ahead and get our feet wet and plot these ordered pairs and see what the line looks like. So I'll put this off to the side. Now, the first order pair is 0, 4. Remember, x is going left or right depending on the sign. But since x is 0, then that means we do not move left or right at all. The y-coordinate is negative 4. So that means we go just strictly down 4 spots. The second order pair is 6, 0. Just means that we go to the right 6 spots, that's your x-coordinate. And since the y value is 0, we don't go or move up or down at all. So 6 to the right and then stop. And the last order pair we need to plot is 3, negative 2. So you can think of this as, if you're driving, you can think of it as north, south, east, and west. So this is saying we're going 3 blocks east, And then from there, we're going 2 blocks south because the y is negative. Now connect your dots. MyMathLab will connect the dots for you. You don't have to manually connect the dots. And your graph should form a straight line. Before we look at another example where we're completing a table of values and graphing the line, did any campus have any questions? Let's look at another equation with a partially filled table, and let's find these values again. Let's look at one with a fraction down here, number 7. Actually, there's no table given, so we have to, a lot of times when we're graphing a linear equation, oftentimes we have to create our own table of values. So I'm going to draw my XY table. Now, normally if y is by itself, then you can plug in any value that you want to for x. But since we have a fraction, we want to pick multiples of 4, multiples of the denominator. That way we can cancel some stuff out and end up with just integers instead of fractions. So we can use -4. 0 is a good choice. And let's use +4. Now, when we plug in -4 for x, we have 3/4 times -4 plus 2. And you guys know that the 4's cancel out. That's why I chose, for x, multiples of 4. That way we can cancel stuff out and not have to plot a fraction. All right, so we have -3 plus 2. So your y value is -1. Next up, let's plug in 0 for x. So we have 3/4 times 0 plus 2. And this part here goes to 0. So our second y coordinate is 2. Again, in MyMathLab, all you would need are 2 ordered pairs. The graphing tool will do the rest of the work for you. Once you plot your points, it'll connect the dots for you. Lastly, let's plug in 4 for x. Again, the 4's cancel out, leaving us with a +3. When we multiply, and then 3 plus 2, that will give us a +5. So we have enough ordered pairs so we can plot these points and get the graph of the line. Any questions from any campus how we got the points before we plot them?
How did you get the first one, the -1?
Okay. 4 can go into itself one time, and there's a negative sign already there. It was -4, so that's really a -1 now that's left over. It's like you're taking a, how can I put it another way? -4 divided by +4 will give you -1.
Okay, but then you're supposed to add it to it, like you did the one at the end.
Yeah, before that I have to I multiplied the -1 times 3, whatever was left over, and got -3, and then add it to the 2 to get our y value. Hope I answered. Did I answer your question okay?
You did, thank you.
You're welcome. Any other campus? Any questions?
So if both numbers cancel out each other, like when you multiply, you'll automatically multiply the other number by 1.
Yes. Now let's plot these points on our Cartesian plane. And let me zoom out. So our first order pair is -4, -1. So that means in terms of directions, you go left 4 and down 1. So left 4 and down 1 is right here. The next order pair is 0, 2. And that just means we go up 2 spots. We don't go left or right because x is 0. So we go up just 2 spots. And the last order pair to plot is 4, 5. That means we're going 4 blocks east and then 5 blocks north. And then we can plot our point. And everything, all our points are what's called collinear, which means they all form a line. So we connect the dots and got the graph of our equation. Again, any questions so far about finding order pairs or graphing lines? Yes, ma'am, Macon.
Okay. So let's say if I was a 5x that went into 4, could I have used number 8?
Yeah, you could use 8. I wouldn't go no higher than 8 because, like 16, for example, or 12, because that may go off the grid.
Yeah.
But 8, -8, those are good choices also.
Yeah, but would it be right if I was to try to?
Yeah, you would still get the same line.
Okay.
So as long as it's a line, it's okay.
Yeah, as long as it forms. For now, as long as it forms a straight line, then you got the correct points. For instance, you said let's use 8 and see if that kind of falls within our line here. If we plug in 8, and I'll just do it down here. Uh, 4 can go into 8 2 times. And then multiply that 2 times that 3 that's already there. That will give us a 6. And then plus 2 would give you a positive 8 for y. So let's see here. I can guarantee if we had enough room, 8 and 8 would actually be on the line. So 8 or -8 are good choices as well. Any other questions from any of the satellite campuses? All right, let's talk about intercepts. The first line that we drew, this point right here is 0, -4, and this ordered pair right here is 6, 0, have special meaning. These are known as intercepts. The order pair is 6, 0. And I'll just come up here. The order pair is 6, 0 is known as the x-intercept. And in my math lab, when you're asked to find intercepts, you have to put them as order pairs. The x-intercept, by definition, just means the point where your line crosses or intersects the x-axis. So that's what the x-intercept means. So that's what the x-intercept means. It's where it crosses, the point where your line crosses the x-axis. And right here, the order pair is 0, -4 is known as your y-intercept. And the y-intercept, by definition, is the point or order pair or the place where your line crosses the y-axis. So if they cross at the x or y intercepts, then they have a special meaning known as intercepts.
So,
yes, ma'am.
So basically, if any other numbers got a 0 in it, it's an intercept.
That's a good way to look at it. In case the other satellite campuses didn't hear, the Macon campus said if they have a 0, then that means they're intercept. Is that what you were saying? Let's look at another equation where we're just going to graph it by using the intercepts only. Let's find the intercepts and also graph the equation. The first step is to draw your XY table. What I like to do is, when I'm picking my points, if I have X and Y on the same side of the equation, then I just simply use 0 and 0. 0 for X and 0 for Y. Now, if we let X equal to 0, then this first part here disappears. And you're left with 4y equal to -8. And just divide both sides by 4, and we got the first order pair. So y is equal to -2. To find the second order pair, we'll let, this time around, y equal to 0 and find x. So we have 2x plus 2x plus 4 times 0 equal to -8. And I got a text from the Warner Robins campus. You don't necessarily need graph paper, but if you want to print out your own, just search on Google and type in printable Cartesian plane or something to that effect, and you can print out your own graph paper to have in your notebook. So thank you, Warner Robins, for that question via text. All right, so this part here in the middle disappears, And we're left with 2x equal to negative 8. The last step, divide both sides by 2. So for the second order pair, our x value is negative 4. Again, as Macon Campus mentioned, whenever you have zeros in your order pairs have special meaning. The 0, negative 2 is your y-intercept. And negative 4, 0 is the x-intercept. And how you know which is which? Well, the y-intercept actually has a value besides 0, and the x-intercept has a value besides 0. So that's how you can easily label the intercepts. Now, all we need are 2 order pairs. If you're sketching this by hand, maybe a third order pair would be good. But all we need is 2. All right, so 0, negative 2 just means we're not going left or right at all because x is 0. We can go down 2 spots. And the order pair negative 4, 0 just means because x is negative, we're going 4 spots to the left. And because your y-coordinate is 0, we're not going up or down at all. We're stuck at negative 4. And our 2 points, when we connect the dots, form a straight line. Good morning. And true to form, we identified the intercepts correctly. This is where it crosses the x-axis at negative 4, 0. And this is the true y-intercept where the line crosses the y-axis. Any questions from any campus about graphing or plotting points? Again, also from the Macon campus, and all the satellite campuses. If you think of a question but you don't want to ask it in class, that's fine. I got both tabs open to check my text messages as well as my email. So if you have a question, you can just send it to me and I'll be glad to answer it on the air. We have looked at different types of lines. Some have gone up or risen up, and some are falling down. And let me zoom out so we can see as comparison. So we can compare the 2 lines. This line right here was going uphill, are rising from left to right. This line is actually decreasing or going downhill or going down from left to right. One important component that we'll be discussing a lot, starting now as a matter of fact, is something called slope. Slope is a ratio, and a simple definition is how far your line, each point rises, over how far each point runs over. And a simpler definition is the change in your y coordinates, and change, of course, means subtraction. And the run part means you're running left to right, so that means the change or the difference in y's. Change in x's, I'm sorry. So that's by definition what the slope is. It's how it describes how the line behaves. Again, rise, which is the y, and the run, which is the x. So let's look at this last line we just did. And you can go from one point to the other point, from one intercept to the other intercept to find the slope. So right here, I'm just going to start here at 0, -2. And I go up 2 spots. If I go up, then that's my rise, or my change in y's. Now, in order to get to this other order pair, we have to run left. And run left means we're going in a negative situation with our x value. So to get to the second order pair, we have to go 1, 2, 3, 4. So we went up 2 spots and we went to the left 4 spots. So the slope for this particular line would be 2 over -4. And that will reduce to -1/2. So that's what slope is. It's just a ratio showing you the behavior of the points, and by definition, just simply rise over run. Let's look at one of the other lines that we graphed and find its slope. Let's look at this first line that we graphed earlier. And it doesn't matter where you start. You can start at any one of the 3 order pairs to find your slope. Well, I'm going to start here. And I want to end up here at this middle order pair. So that's all you're doing with slope. If you had to find it graphically with a line, you're going from one point to just a second point. So that means we have to rise up 1, 2, 3 spots. And to get to the second order pair, we have to run over in a positive direction 1, 2, 3, 4. So by definition, the slope of this particular line is rise over run, or just 3 over 4. If you notice in our original equation, this was our original equation. No coincidence that our slope is 3 over 4, and we had 3 over 4 in the equation itself. This leads me to telling you the next type of equation. We talked about an equation that's in standard form. In other words, x and y on the same side equal to some positive or negative number. This type of equation is in what's called slope-intercept form. where M is your slope, and B is the y-intercept. Well, let's see if that came out to be true. Well, we already know that the slope of our line came out to 3/4, so that checks out. And according to our equation, the y-intercept occurs at 2. That's also true because our y-intercept is here at 2. So that's the other major type of equation that we'll be dealing with, one that's in what's called slope-intercept form. Any questions, y'all, about finding slope this way?
Should it be two different numbers for this answer? Because it's two different intersecting points.
Good question. For this answer, not really, because the B just represents where it crosses the y-axis only. So here you wouldn't need two answers.
So you could just choose whichever point you want to choose, or?
Right. If you are given the graph and nothing else and just miscellaneous order pairs, you can start at one point. We could have started here if we wanted to. If we started here, then that means we would rise up 1, 2, 3 points, and then went over 4. So the slope, the ratio between the points will be the same. Excuse me. Any other questions? Any questions from the satellite campuses? I want to go over the special cases. Let's look at number 5, and also we'll do number 6. It's off screen right now, but we'll look at it. All we have to do here is graph this equation, x plus 3 equal to 0. Well, we have to solve the equation and get x by itself first. So subtract 3 from both sides. And the equation that we're trying to graph is the line x equal to negative 3. Now you still draw your xy table. Now I can pick anything that I want to for y, just any random negative, positive, or even 0 values. I'll just say negative 4, 0, and positive 5. It actually doesn't matter what you pick for y, just randomly generated points. Because no matter what we pick for the y value, according to our equation, x is always going to be a constant negative 3. So that means going down the x column is nothing but negative 3's. Well, just like that, we got 3 easy ordered pairs to plot. So negative 3, negative 4 means we go left 3 and down 4. Negative 3, 0 means we go to the left 3 and then stop. And finally, -3, 5. We go to the left 3 and up 5. And give me just a second. I'm answering an email. It's actually off campus, so we'll plot these points and then we'll discuss what the slope will be if it exists at all. All right, so when we connect the dots, we have a vertical line. A vertical line, if you're asked to find its slope, a vertical line has no slope. It's just going straight up and down, no slope at all, or undefined. Would be acceptable. So if you have x equal to any number, positive or negative, then expect to draw a vertical line with no slope. Let's look at the other exception, other type of equation. We have the line y equal to +7 that we need to graph and find the slope for. The first step is to draw your xy table. Turning the tables, we can plug in or plot, pick anything we want to for x. Let's just say -1, 0, and +4. Because no matter what we pick for x, y is always going to be a constant 7. So going down the y column is nothing but 7s. And just like that, we got 3 easy ordered pairs to plot. So -1, 7 means we go to the left 1 and up 7. Zero 7 just means we go up 7 spots and stop. And the order pair 4, 7 means we go east 4 blocks and north 7 blocks. And when you connect the dots, you get a horizontal line. The slope for a horizontal line is always 0. And that just means that it's not going up, it's not going downhill. It's leveling off on ground zero level.
So on this one, you can't put undefined, you'll have to put 0.
Oh, good question. They're mutually exclusive, so that means the answer could be 0 or undefined. It can't be it's either 0 separately or undefined separately. You can't put 0 or undefined together. Any other questions about these exceptions to the rule? Now, what if you're given 2 order pairs and that's all, and you have to find the slope between the 2 order pairs? There's a formula that you can use for this specific occasion. This is nothing new to our original rise over run or change in Y over change in X definition. We just rewrote it with letters. So we just take the Y coordinates and subtract them, divided by the X coordinates and subtract them. So let's start with this example. All we need to find is the slope between these two given points. The first step is to label your order pairs. And I just think of my first order pair as my first X, or X sub 1, and my first Y coordinate. And my second order pair as my second X, or X sub 2, and my second Y coordinate, or Y sub 2. Now, since we've labeled all of our values, let's plug them into our formula. Y sub 2 is negative 8. Y sub 1 is 1. That will happen between vacuum cleaners and folk singing. That will happen. The X coordinates, let's plug those in carefully because we got negatives involved. X sub 2 is 7 minus. Our X sub 1 is also a negative, so we got a double negative happening in the denominator. So upstairs, when we combine the Y's, that will give us a negative 9. And you guys know a double negative means a positive sign. So down there, it's really 7 plus 5, or just 12. And if you get a fraction answer, go ahead and reduce it to lowest terms. So we can divide each number by 3. So our final slope is negative 3 over 4. From the slope, if we don't know anything else, we know because the slope is negative, then that means our line, if we had to graph it, will fall from left to right, or decrease. If our slope was positive, then that means our line would actually rise from left to right or go uphill. Any questions before we look at another example? All right, let's look at this example. All we're doing here is finding the slope between the 2 points. So the first step is to identify your parts of your formula. So our first order pairs are x1, y1. And your second order pair is your x sub 2 and y sub 2. So let's write down our slope formula and plug in our given values. Upstairs, when we plug in our y coordinates, we have 8 minus 4. And in the denominator, when we plug in our x's, that will be 3 minus 3. So we end up with 4 over 0. You know, when you put this in your calculators, you'll get an error message or invalid input or cannot divide by 0. If you get an error message, then that means your slope is undefined or there's no slope. We automatically know that if our slope is undefined, then our graph would be a vertical line. Again, any questions about finding slope this way?
I do have a question though. So you say if there's no slope, that means it's vertical, but what about horizontal? How do we know it's horizontal?
Good question, Macon. For the other satellite campuses, the question was, how do you know that you'll have a horizontal line or the slope 0? What if it was the other way around? Well, if it was the other way around in our problem and 0 was on top and our denominator was just a number, then that is equal to 0. And that would indicate a horizontal line. Any other questions from any of the other campuses or here in Macon? Yes, Macon.
Okay, so we ended up with 4 over 0. So if anytime like just one number and not like two, like a whole fraction, that's when it's no slope.
Right. If 0's in the denominator, automatically defined. And for further confirmation, if you can always put that fraction in your calculator, and like I said, if you get an error message, that means undefined slope. Let's go back to the first order pairs, and I want to talk to you about the concept of a function. A simple definition of a function, and a function can be notated this way. You can use any letter in the alphabet, but normally we use like this notation, or we can use G. This is not multiplication. This just reads f of x or g of x. And these are actually the same thing as your y coordinates. So anytime you see f of x, that means you're looking for the corresponding y value. Or the same thing with g of x, h of x, etc. Now for a relation, and by the way, a relation is any set of order pairs. Now, for a relation to be defined as a function, all your x coordinates must be different. Again, for a relation or a set of order pairs to be defined as a function, then all your x values must be different or unique. So for this first example, if we were to plot these points and draw the graph, we already knew that it would end up being some type of line that's falling down from left to right. Because the x-coordinates are different, then this particular line would be a function. Again, if your x-coordinates are totally different, then that means you have a function by definition. The y-coordinates can repeat as often as they want and still be a function, but the x-coordinates have to be different. Let's look at the other order pair. We want to find out, is this particular line a function? Well, the answer is no. The reason why this is not a function is because the x values repeat, or the x coordinates repeat. So this would not be a function at all. Again, if the x coordinates repeat, then your line or relation is not a function. Another way that you can determine if a relation is a function is graphically. If you're given a graph, you can determine if a relation is a function by something called the vertical line test. And the vertical line test, I'm just going to describe it and show it to you. Vertical line test means if you can draw a vertical line anywhere through your relation or your graph. And if that vertical line only touches or intersects your line or your relation at just one point, then it would be a function. So if we draw a vertical line here, 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 no matter where we draw the vertical line in our line, each time it only intersects or crosses at just one point. Okay? So this line here, by the vertical line test, is a function. Let's look at another graph. Oh, sorry, you can't see that too good. Given this graph, we need to determine with the vertical line test if it's a function or not. Well, when we draw a vertical line through our graph, and just follow my pen here, it touches one time here, and it touches again on the other side of the graph. Because our vertical line intersected at more than one point, then this particular graph is not a function. So if you're given the graph of any type of relation, if you draw a vertical line and it crosses at more than one point, like it did here with this graph, crosses more than one time or intersects more than one time, it's not a function. Is everybody okay with the vertical line test? Oh, Macon, yes ma'am.
Okay. So, if you draw, okay, how long does the line have to be there before you?
Really no length. Just so long as it crosses just one time each time. Like here, you didn't have to, I didn't have to draw those other vertical lines. I could have just drawn this first one. And it only intersects the line just one time.
Okay. So
Yeah.
as long as it's like in the middle, not two of them at one time.
Right. As long as it does not, our vertical line does not cross more than one time, then we're good. We have a function.
Okay.
From the satellite campuses, did y'all have any questions? Okay, I want to go back and talk with you about, speaking of functions, we'll look at that. Actually, we'll do that now. And then we'll go back to slope in just a minute. As I mentioned, a function, if we have y equal to negative 2x plus 1, this is, if you were to test this or plug in x coordinates, this is a function. It's just, a line is a function. Now, we can, sometimes, you might not see the y. You might see another notation like f of x or g of x. F of x, y'all, is the same thing as your y value. So if you see f of x, that means you're really looking for the corresponding y value. Now, given this particular function, let's find a few values. All right, given this function, f of x equal to negative 2x plus 1, we want to find these three values, f of negative 3, f of 0, and f of negative 1/2. So write down your function again. And the first value that we want to find is f of negative 3. All that means is everywhere that you see an x in your function, plug in negative 3. On the left side, this is not multiplication, it's just a way to write a function. According to your order of operations, we have to multiply negative 2 times negative 3 first and get a positive 6. And then add 1 to that to get 7. Now, how you translate this is as an ordered pair if you had to graph it. This is saying when x is -3, your corresponding y value would be 7. All right, let's find the next value, f of 0. So that means in your given function, everywhere you see an x, replace it with the number 0. So we have -2 times 0 plus 1. And thank y'all. Keep sending those questions. If you don't ask them in class, you can send them to me via email or text message.
Where did you get the numbers from? Like the -3, 0, and 9?
Just made them up. Yeah, I just randomly made up some numbers to plug in.
So would it have to be fractions or something like that? Or it could just be?
It could be any random, whatever my math lab asks you to plug in. So it could be any random, any number. It could also be letters too, which we'll take a look at. So this will give us 0 plus 1 or just positive 1. And finally, we need to find the value of f of -1/2. So going back to your original function, everywhere you see an x, now replace it with -1/2. So right here, the 2's cancel out. 2 divided by 2, or -2 divided by 2 would leave you with a -1. -1 times -1 gives you a +1, plus the 1 that's already there. So when x is equal to -1/2, your corresponding y value would be exactly 2. Yes, ma'am. Got a question in Macon. Go ahead.
Okay. Cancel out the 2, then and this is the -1, and then you get -1 plus 1 plus 5. Oh no, you did times.
Times.
Okay.
Yes,
That's
ma'am.
why I got lost. Okay.
Any questions about finding values for functions? Not a guarantee, but I think Blackboard has a chat tool or something to that effect, or a collaborative tool. If I can figure out how to work it, I may open up a chat room during our class time, and that way it make it a heck of a lot easier for you to ask questions if you're on one of the satellite campuses and I'm not in person there to help you. But for now, and even here in Macon, again, if you have any questions, you can just say, hey, Mr. Arnold, I have a question. Tell me what campus. Or you can email or text me. I don't mind helping you in any of those 3 ways. What if you had this function? And let's find a few values. As y'all know, y is the same thing as f of x. And tell you what, let's find the following functions. F of -3 4. And also f of the letter A is an apple. Let's find f of -4 first. All this means, this notation, is that wherever you see an x in your function, replace it first with -4. So we have f of -4 equal to 3 times -4 squared plus 4 times -4 plus 2. Now we have to follow order of operations, so that means do the -4 squared part first. So -4 squared is -4 times -4, and that will give us a positive 16. So when we multiply that 16 by 3, that gives us a positive 48. In the middle, we're multiplying a positive 4 times a -4. So a positive times a negative will give you a -16. And bring down the plus 2. Now, let's go left to right. 48 minus 16 gives us 32. And 32 plus 2 gives you 34. So that would be the value of f of -4. When x is -4, your corresponding y value would be positive 34. Let's find the second function. The second time around, everywhere you see an x, that means you plug in an a. So we have f of a equal to 3a squared plus 4 times a plus 2. And we can't do anything more to that function. Any questions about finding values of functions?
So it's not simplified, the answer is not simplified.
Right, we can't factor this particular last answer, so we just leave it like that.
But like with the last answer, like the one before that, the 1 plus 1, that was just one of the ways we did it. So we use all of the ways we did it as the answer. Because the bottom one, that was supposed to use all 3 of them.
Depending on what my math lab gives you to find the value of the function, that will change. Like, are you referring to these 3 up here?
Yeah, because it's like we only had like one answer, but it's like 3 different ways we solved it. So which answer we're supposed to use?
Oh, it'll be in parts. It'll be like multiple parts. You find f of -3 first and put down that answer as 7. And then it'll ask you to find, in a separate part, f of 0 using the same function.
Okay, I got you.
Yeah. Yes, ma'am. Did you have your hand up?
Oh, she asked, well, you answered it, not me.
Okay. Any other questions? Satellite campuses? Okay, I want to go back to slope for a minute. I've already talked to you about the different ways to find slope using our regular formula. So far, these are the three ways that we can find slope. With the formula, when you're given two order pairs and nothing else. If you're given a graph, and you can use the rise over run definition. Or if your equation is what's called slope-intercept form. There is a fourth way that you can find the slope. If your line is in standard form, in other words, x and y are on the same side, and your constant is on the other side, it could be positive or negative, then here's a shortcut way to find the slope. You can use this formula, negative a over b, to find the slope of a line that's in standard form. Where a is the number in front of your x, and b is the number in front of your y. Let's look at these two standard lines. You don't have to get y by itself. You don't have to get y by itself and put your line in slope-intercept form to find the slope. You can use your shortcut formula up here. For the first equation, let's identify a and b first of all. A is 2, and b is negative 7. So let's write down our slope formula. M is equal to negative a over b. That negative sign is part of the formula, so don't leave it out. A is 2, but it's negative according to the formula. B is negative 7. And all we have to do is change our answer because we have a negative divided by negative. So our answer would be a positive 2 over 7. And just like that, you found the slope very easily. We didn't have to get y, solve for y, get y by itself, or get it in slope-intercept form, or this form up here, to identify the slope. You can use this handy formula only when you have a line that's in standard form. Let's find the slope of the second line. First, identify A and B respectively. So A is 4, and B is 8. And let's plug in our values for A and B respectively. A is 4, but it's negative per the formula. And B is 8. The only thing I ask you to do with fraction answers is simplify them or reduce them to lowest terms. Yes, ma'am.
It wouldn't be negative 8. because it's a negative or positive?
Uh,
Oh, no, it won't, because it's positive sign.
right.
Oh.
That's a good question, though. If you're trying to figure out if your A and B are positive and negative, yeah, just look at the signs in the original equation. We can divide both numbers by 4. So our slope here is -1/2. So keep this formula handy, especially when you run across a line in standard form and you got to find its slope. Any questions how to find slope this way? I want to go over one example with you on why we'll be using this particular formula to help us. But first of all, let me go over the difference between parallel and perpendicular lines. How you know that lines are parallel is if they have the same slope. So parallel lines have the same slope. How you know that lines are perpendicular is that they have their slopes are opposite reciprocals of each other. And let me explain what that means. If you had one line had a slope of -2, well, that's understood to be -2/1. The opposite of a negative sign is a positive sign. And the reciprocal of 2/1 would be 1/2. So that's what I mean by slopes having opposite reciprocals, is they got different signs and the slopes are flips of each other. Another example is if you had -3/4 for one slope, well, the slope of the line perpendicular to that line would be just 4/3. Again, opposite signs, slopes are reciprocals of one another.
So basically, both of them have to be like opposite. Like one have to be negative, one have to be positive, and then one they have the same number.
Right. Yeah, they have. That's a good point. They have for them to be the lines to be perpendicular. They have to have the slopes have to be opposite signs, and they have to be flips of one another.
But can the bottom be negative?
Sure. Yeah, the bottom could be negative. You could write this as 3/-4, and it will still be a positive flip. Let's look at one system of equations and determine how these lines behave. Again, you don't have to get y by itself or put it in what's called slope-intercept form. Because each line is in standard form, we can use our shortcut slope formula. So we have m equal to -a/b. For the first line, a is +2, but it's negative, according to our formula. So we have negative 2 over b is 3. So the slope of the first line is negative 2 over 3. Now to find the slope of the second line, you use the same shortcut formula and again identify a and b. For this second line, a is 8, but it's negative per the formula. And b is positive 12. And we can reduce the negative 8 over 12 by dividing each number by 4. So our slope for the second line is negative 2/3. Since I'm here in Macon personally, let me ask you, because we got the same slope, what can you tell by these lines?
They're parallel.
They are parallel to each other. Again, because we got the same slope, that means the lines are parallel to each other. Oh, there's a handy website, bless you, that I don't mind y'all using. It's very user-friendly, it's free to use. And you can use this website, say you have to graph a line in my math lab, or you can run it through Desmos or plot it or type in your equation in Desmos and see if your line is correct before you put it in my math lab. So Desmos.com, free website. I highly recommend it. I use it a lot. Let's look at another system. Now, this is kind of a mishmash of different formulas and different forms. We can write the first equation in what's called slope-intercept form. And slope-intercept form is the form y equal to mx plus b. So we just require one step to get y by itself for the first equation. And that is subtract 5 from both sides. So we have 11x minus 5 equal to y. Let's rewrite it. We can just swap everything around where it's in the proper order. So we can definitely rewrite this as y equal to 11x minus 5. Now, in slope-intercept form, the slope is your m, or your number in front of your x. So for this first equation, the slope is positive 11. Now, for the second equation, I'm going to swap the x and the y around so to be in the proper standard form. Now, the second equation, we don't have to solve for y or get it in slope-intercept form. We can use our shortcut slope formula. So write down your formula, m equal to negative a over b. And Macon, since I'm here, what do y'all think A is?
-1.
Very good. Yeah, there's no number in front of the X, but it's assumed to be a 1. So yeah, your A is -1, and your B is 11. And again, we're trying to determine if these lines are parallel, perpendicular, or possibly none of the above.
Is parallel the same?
Go ahead.
It's perpendicular,
Okay.
because that would be understood as 11 on line. It's negative, and then
Okay. Yeah, this first slope is understood to be 11/1. And this second slope is actually opposite sign and it's a reciprocal of the first slope. So, perpendicular. The good thing about this section of Lesson 6 is that you have one of three choices. They're either as you mentioned, the same slope, equal slope, perpendicular slope with the negative or opposite reciprocals, or you might not have neither case. That is possible third choice.
Why did the first part did you use that formula instead of the negative A over B?
We could have moved the y to the left side also and put it in standard form. There were different ways to get that slope. If you, as I said, if you wanted to, you could, with the first equation, kind of keep it in line with this one since it's in standard form already. We can move the y to the left-hand side by subtracting y from both sides. So we have 11x minus y equal to positive 5.
So when you say in standard form, that just means like with the y on the left.
Yeah,
and
standard.
the x plus the b is going to be positioned like that.
Satellite campuses, the question here in Macon was, standard form means your y is on the left side. That's right. The x and the y are on the same side, and your number's on the other side.
Okay, so it's in the mx plus b form. That's what the standard form is. Mx plus b. Y equals mx plus b.
Oh, that's totally separate. That's just slope-intercept form.
Okay, so just have to erase that way.
And anytime x and y are on the same side, that's standard form. Let's use our shortcut formula here. We should get the same slope as before. A is 11, but it's negative. And B is understood to be a -1 in front of the y. So yeah, we do get the same slope working it. Feel free to work it out this way if you want to. Did that answer y'all's questions about standard form and about working it, why I worked it a different way? Satellite campuses, any questions?
But on the first one that you did, the one that is -1, and then with the second one, yeah, with that one, we use -y. So both of them got negative.
Yeah.
So it wouldn't be perpendicular because both answers got negative.
Oh, but right here the negatives.
Oh yeah, they cancel out. Yeah, I got you.
That's a good way of putting it. Your negative signs here will cancel each other out. Make it a positive. The last thing I want to go over with y'all, this is also from lesson 6. And I'll just put these other equations up here for us. We've already used and talked about standard form and also slope-intercept form. The third major equation that you're going to be using is something called point-slope form. And the title says exactly what you'll be plugging in. You'll be plugging in a given point, which is your x1 and your y sub 1, just like slope. And you'll be plugging in your slope to find the equation of a line. So these are the three main forms of a line that we're going to be using in lesson 6.
What is that sign beside that? The formula is a y minus y and then it's some small.
Oh, I'm sorry, that is mighty small. Let me write this bigger. Okay. Yeah, just y minus y sub 1 equal to m times x minus x sub 1. Where x sub 1 and y sub 1 is your given ordered pair. And of course, m is your slope. So that's the third form that we'll be using to find the equation of a line. Let's look at this first example that I put a red dot by. Write an equation in standard form of the line passing through the points 9, 2 and negative 6, 5. Well, if you're given two ordered pairs and nothing else, at least you can find the slope between the 2 points first of all. So let's use our other slope formula. M is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. In which your first order pair is your x1, y1, and your second order pair is your x2 and y sub 2. So let's plug in all of our x's and y's carefully into our formula. Upstairs we have 5 minus 2. And then downstairs we have negative 6 minus 9. So this will give us 3 over negative 15. And we need to reduce this before we plug it into one of our other forms. We need to reduce this to negative 1 over 5. Now the next step is to figure out which of these three forms are we going to be using. I'm leaning toward the point slope form because we're given a point. You can use either point, by the way, to plug in, and we just found the slope. So let's use our point slope form. And it is y minus y sub 1 equal to m times x minus x sub 1. Now the point that you choose does not matter. You could plug in negative 6 for x sub 1 and 5 for x sub 2, y sub 2, I'm sorry. Or you can use the first order pair. Folks, it does not matter which order pair you plug into your form, you'll get the same equation. Since I labeled this first order pair as x1 and y sub 1, I'll plug those in. So y sub 1 is 2. Our slope, or m, we just found is negative 1 over 5. And our x sub 1 is 9. Now, probably the best thing to do is get rid of the fraction. So let's multiply both sides. Because we have a negative here, let's get rid of that too. Let's multiply both sides by negative 5, the given denominator. Now here in the middle on the right hand side, watch what happens. Negative 5 divided by negative 5, that just leaves you with 1, right? So the negative 5's cancel out, and you're just left with 1. Anything that's already in parentheses is not affected by the outside multiplication. So the x minus 9 stays as is. Let's multiply negative 5 or distribute it times the y minus 2. So that would be negative 5y plus 10. We really don't have to distribute that 1. We can actually drop it off, because on the right hand side that's just equal to x minus 9. Now before we get our answer in standard form, and y'all know standard form means we have to get the x and y on the same side. Did any campus have any questions up to this point? One thing about standard notation that I forgot to mention, although I will not count off for it, technically the x term has to be positive according to algebra, but I will not mark it wrong if you have a negative answer. So what I'm going to do to get the x on the left-hand side is subtract 1x from both sides. So that gives us up here negative x minus 5y plus 10 equal to negative 9. Now it's almost in standard form. We already got x and y on the same side, but we need to get all the constants on the right hand side. So subtract 10 from both sides. So our final answer in standard form would be negative x, or just negative 1x, minus 5y equal to negative 19. Y'all, just in case my math lab wants your x to be a positive term, then one thing you can do is multiply the entire equation by, in this case, the negative 1 to change the x to a positive 1. Again, only do that if my math lab will mark your answer wrong and it's looking for your x coordinate to be, your x part to be positive. But if you put this answer down with the negatives, then I'll actually count that correct. To me, that's just as correct as the one with the positive x. Any questions about finding the equation for a line? Okay, let me sum up because I was jumping around between lessons.